Hello and welcome to our today's discussion where we start talking about game theory. Now, what is a game? Game is a simple competitive situation where one person wins at the cost of the other, where one player wins at expense of the other, where gains of one person means loss of other person. So, it is a competitive situation where we are fighting for same piece, same bite, same market. Such kind of competitive situation is known as game for the purpose of game theory, where there are multiple players, not only two players, there can be multiple players fighting for same market share. So, the idea behind game theory is that there are multiple players fighting for the same trophy, fighting for the same cup, fighting for the same customer, fighting for the same market share. So, when I win, it essentially means that someone else has lost that thing. If I win a customer, it essentially means that the other one will not be able to sell to that customer. So, this is the idea behind game, and what we will discuss will be game theory. A theory, a science, some algorithms, some methods targeted at finding out the best possible strategy for me as a player. If there is a game like situation, if I am playing a game, what is the best strategy for me? If I am selling in a market, how can I ensure that I sell more than my competitor? This is the idea behind game theory. Now, there will be certain methods that we will be studying, there will be certain limitations, certain assumptions that we will be following, but this is the idea behind games. It is a competitive situation where one player wins at the expense of other. One's gain comes from others' loss. Now, we will take a situation, a very simple situation. Let us say we have players and periods. We have, let us say, 1, 2, 3, there could be n number of players. We are taking only 3 for simplicity. Now, periods, first period, second period, third period, fourth period, fifth period, sixth period, seventh period, and there could be n number of periods. So, we are taking a very simple situation where we have 3 players and we will simulate the situation for 7 periods. So, 3 players and 7 periods will go for a simulation. Now, there can be more than 3 also, there can be 2, there can be 10, there can be 20, there can be 100. We are taking only 3 to understand the scenario. Now, let us suppose the situation is 20, 40 and 40. What is the total market size in such case? Suppose total market size is 100 and market shares of A, B and C are 20, 40 and 40. Now, suppose as the time advances, we move to period 2. We will reduce these periods. We move to period 2, let us say, and the shares change to, let us say, 35, 35 and 30. Now, what has happened? Market share of A has gone up to 35. Market share of B has come down to 35, C has come down to 30. So, A has won something, A has gained something. A has gained at expense of B and C. The 15 that A has won, 5 were lost by B, 10 were lost by C. So, if I put it up this way, let us say situation of A is plus 15. What about B and C? Minus 5 and minus 10. Looks good. What about the total situation? 35 and 35, 70 and 30 would be 100. What about transferring, shifting of shares from one place to another? Plus 15 and minus 15. The total is still 0. Fine, no issues. Player A won at expense of B and C. Suppose our shares for period 3 change to, let's say, 40, 35 and 25. What is the scenario? If we talk of incremental, 35 has gone up to 40, meaning a plus 5. 35 is still at 35. 30 has come down to 25. And what is the total scenario? Total scenario is still 0. And what about market? Market is still at 100. Now, if we have a look at period 2 and 3. In period 2, what happened? A snatched shares of B and C. In period 3, in a sense, we can say that A has snatched share from C. B is still hanging on to its own share. Yes, it might so be possible that A took away 20 from C, B took away 5 from A took away 10 from B. So, those shiftings are possible, but the core idea is that there were 100 in the market, still there were 100, a selling potential of 100 in the market, still a selling potential of 100 in the market, and this is how the shares are shifting from one place to another. Now, any particular combination is possible. C could win from A and B, C could win from C, B, C could win from A. Any combination is possible. So, let us expand our discussion to certain more periods. This is also possible. It is not the case that A will always win. A might lose also. A has lost, B has won, and even C has won. What is the scenario? A loss of minus 5, a gain of plus 5, and 25 to 30, again a gain of plus 5. Fine. So, what has happened? Complete scenario would be plus 5 and plus 5, plus 10 minus 5. So, it will give me a complete picture of complete scenario of plus 5, whereas the market size this time, because there is a complete scenario of plus 5, definitely the market has expanded because people have gained 5 additional units. Let me check. This is 75 and 105. So, what is happening? This time market has expanded. Market expanded by 5 units. And of course, the competition, of course, the game between A, B and C was going on. Someone was winning, someone was losing. Still, I will say that B and C have won at expense of A. Because there were additional 5 units. Even if we cancel these two out, C has won. C has won at expense of A. Because if C had not won at expense of A, then A also would have got some units from 5. Proportionately, these 5 additional units would have been distributed among A, B and C. But they were not distributed equally, rather they were concentrated between B and C. So, I will definitely say that C has won from A. A has lost. It is simple mathematics that if there is an increment of 5, it should have gone proportionately, but it has not gone proportionately, rather A has actually been in a loss of 5. While B and C have won something. Now, this could go on and on. We could see a 40, we could see a 45, we could see a 55, making it plus 5, plus 5, plus 25. So, the complete situation becomes 85, 90, 140. And if we look at the potential size of market, 5 and 5, 10, Size of market has also gone up by plus 35. Now, what has happened in this case? Everybody is at plus. A is at plus 5, B is at plus 5 and C is at plus 5, plus 25. So, where does that statement stand? That one player wins at expense of the other. Everybody is winning, nobody is losing. But if we look carefully, definitely someone might be losing, because there has been a total expansion of 35 and majority of that 35 has been absorbed by C. Ideally, this 35 should have been divided between A, B and C as 11, 11, 11, 11.66, 11.66. But what happened? C absorbed 25 of those, while A and B got only 5. So, this means C has got 25 instead of 11.66 of equal distribution. Meaning that from where did C get these additional units, which is what, 13.33? 13.33 units. So, where are these 13.33 additional units coming from? These are coming from A and B. So, the idea is one player definitely wins or gains at the expense of other. Now, if we have a look at these scenarios for 5 periods, this could go on. If we have a look at these scenarios 1, 2 and 3, look carefully, we have a 0, we have a 0. So, the transition in these cases is 0. While if we have a look at these scenarios, the transitions are not 0. In one case it is plus 5, in one case it is 35. So, whenever the transitions are 0, we call it a zero-sum game. Whenever transitions of complete game, wins, losses of all players, if there were 10 players, I would add wins and losses of all 10 players. If there were 200 players, I would add wins and losses of 200 players. And if sum of all those wins and losses is 0, then we say that it is a zero-sum game. And if I impose another restriction that there will not be A, B, C, D, E, F, there will not be 3, 5, 10, 20 players, there will be only 2 players. Only 2 players, A and B. Then we call it a 2-person zero-sum game. So, what is a 2-person zero-sum game? Because we are studying as students of operation research, we will be restricting our games to 2-person zero-sum games. 2-person means there are only 2 players. I will not be taking calculations for 3rd, 4th, 5th. In fact, they do not exist. There is no C, D, E, F. There are only 2 players. So, if there are only 2 players in a game, it is known as 2-person game. If the transitions between 2 players, the sum of transitions is limited to 0, then it is known as a zero-sum game. So, 2-person zero-sum game. This is an important point from perspective of our syllabuses, from perspective of our examinations, and even from perspective of what we are about to learn. Even from perspective of how I will design my problem, of how I will write down my problem. In operation research, there is a fixed method for writing down any problem. So, whatever method we will be studying over here will strictly be restricted to 2-person zero-sum games. It will make sense only if we are talking of 2-person zero-sum games. Yes, these 2-person zero-sum games can expand to 3, 4, 5, 6, n number of players. They can expand to a situation where they might not be zero-sum games. But those are extremely huge situations. In such situations, where we do not have 2-person, where we do not have zero-sum games, we solve those games using simplex. We formulate those games as an LPP. The idea is whatever we will be studying over here in game theory, whatever we'll be studying over here in game theory, it will be a two-person zero-sum game. And whenever it is not a two-person zero-sum game, the only alternative to solve that kind of game, all the games which are not two-person, which are not zero-sum, there is only one way to solve them, and that is linear programming. That is simplex. So here we'll not be talking of solving a game using simplex, at least not on board, at least not on paper and pencil. Yes, in the end we'll take certain games which we'll solve using simplex. So if I could solve two-person zero-sum game using simplex, I could expand it to 3, 4, 5 players also. Fine. So for now we'll be restricting our discussion to two-person zero-sum games. Two-person means there are only two players. Zero-sum means the transitions over periods are restricted to 0. How will two-person zero-sum games look like? Somewhat like this. $40-60. Now if it is a 30, definitely this has to be 70. If it is 20, if it goes up to 45, if it reaches 58. Remember, we are writing down a two-person zero-sum game. Why are we restricting ourselves to two-person zero-sum games? Reason is, I have written only this much information. Now, can you tell me what we'll be having over here? Definitely you can tell me. Why? Because the market size was 100. This time also market size will be 100. And it is a two-person. Of course, I have taken only A and B, so it will be a two-person. It is a zero-sum. This is very important. Zero-sum is very important. Why? Because if I am losing 10, then definitely the other player is winning 10. Definitely will have an 80 over here. So I need not tell you that what will be the values over here. You already know what will be the values over here. Why do you know? Because of this zero-sum. Because I told you that these are zero-sum games, you already know that what will be the values over here. Can you tell me what will be the values? We'll have values of 80, 55 and 42. This is why we are making use of zero-sum games. Because to start with, I told you that we'll not be talking of 3, 4, 5, 6 players. We'll only be talking of 2 players. Because they are easier to understand. In simplex, we saw that 2 players are easier to plot. We can solve it graphically. As soon as variables increase, we need to go to simplex. So things get complicated as number of players increase. So what we did was, we restricted ourselves from n number of players to 2 players only. And now, by making it zero-sum, I brought down even these 2 players, even information about these 2 players, I brought down the information about 2 players to 1 player. I only need to check information about 1 player. If I know information about 1 player, the other player is obvious. So even I need not care about the other player. I'll only be thinking about 1 player. You had 20, 45, 58. You already knew that the second player would be having an 80, 55 and 42. This is what zero-sum game does for us. That we need to concentrate only on 1 player. You concentrate on 1 player, it is obvious that the gains or losses are coming from other player. What do I mean by that? If I just tell you that A has 120 units, you know that A has now gone up to 60. Now I need not tell you that what has happened to B, because you already know that A has lost 20. What is a game? Game is a competitive situation where gains of one player are coming at expense of or loss of other player. And because it is a zero sum, so gains and losses of two players are exactly same. In the previous example where we had three players A, B and C, their gains and losses were matching at times they were not matching. In advanced stages, we saw in period 6 and 7 or rather 5 and 6 that the gains and losses were not matching. But this time, because it is a zero sum game, the game theory definition is one player wins at expense or loss of other player, and the gains of one player are equal to losses of other player. This is zero sum. So, if I tell you picture of situation of one player, you can understand situation of the other player by yourself. Now, if I tell you that this player has lost 30 units, 60 is down to 30 because I lost 30 units. You already know what has happened to B. You already know that B has won 30 units, gained 30 units. I only talked about A losing 30, but you know that A losing 30 means B winning 30. 40 plus 30 would be a 70. And are all these games zero sum? I have 100, again 100, another 100. This is 2% zero sum games. I hope this is clear that what is 2%? Only two players. Zero sum, the gains of one are equal to losses of other. This is zero sum. If I add all the transitions, plus 20 minus 20, they'll come down to 0. Minus 30 plus 30, they'll come down to 0. So 2% is a separate issue, zero sum is a separate issue. In previous example where we had 3 players, there also we saw there can be zero sum games in 3 players. In 20 players also there can be zero sum games. Zero sum means that the transitions or gains are equal to losses, because net will be 0. While 2% means we are limited to 2%. Yes, there could have been a situation where we would have had a plus 10 and minus 5. What does this mean? 30 plus 10 is 40, 70 minus 5 is 65. The market has gone up to 105, and if I talk of losses, these are not 0, telling me that this is not a zero sum game. So be careful. 2% has got nothing to do with zero sum has got nothing to do with 2%. 2% is telling me that only 2 players are participating. Zero sum is telling me that transitions, the gains are equal to losses. Sum of transitions is 0. This is zero sum game. So this was 2% zero sum games. Now before we try to understand how to solve these games, there are certain conventions that we follow. And those conventions go like this, that we will be having a row player. We can call him R or we can call him, you could call anything. It could be a PQRS, it could be a Pepsi and Coca-Cola. But for convention means when I put an X in mathematics, we know that it is an unknown. Let value of number of pens bought be X. So it is a convention that when I write small x, you already know that it is a variable, it is an unknown variable. So similarly, we have a convention that row player is called either R or A. Similarly, we have a column player. He is called either C or P. R indicating row player, C indicating column player, or you could simply call them A and B. We have player A, player P. This is called their payoff matrix. This is called their payoff matrix, and payoff matrix specifically for A. Whatever I will be writing over here, it is payoff matrix for It is a game, it is a perspective of A. This game is written according to row player. What do you mean by the game is written according to row player? What do we mean by? Game is written according to row player. It means that if I put a 4 over here, what does this 4 mean? That row player or player A or player R, when he selects second strategy, what are these? Strategies. What are these? Strategies. This 4 is telling me whether when row player selects strategy R2 and column player selects strategy C1, R2, C1, the return is 4. What does this mean? That when row player selects R2, when column player selects C1, the return is 4. What do you mean by return is 4? It is a payoff matrix for A. There is a return of 4 for A. What does a return of 4 for A means? It means there is a loss of 4 for B. Because we are taking only 2-person zero-sum games. Fine. What are we saying? That if you pick this combination, that row player takes strategy R2, column player takes strategy C1, then the return would be 4. Return of 4 for A. I need not say return of A will be 4. I'll simply say the return is 4. Return of 4 is obviously for player A, because this game is written from perspective of all these numbers are for A. All these numbers are from perspective of A. Whatever I write over here, it belongs to A. Now, if I say in a 2-person zero-sum game that A has gained 10 units, it obviously means that B has lost 10 units, because it is a zero-sum game. If I tell you that A has lost 40 units, it obviously means that B has won those 40 units. So, if there is a -7 over here, what does this -7 tell me? That if row player picks R1, column player picks C4, my payoff will be -7. If row player picks R1, column player picks C4, this combination will give me a return of -7. This will give me a return of -7. Who am I? I am the row player. This game, these numbers are for row player. So, a -7 tells me that I have a gain of -7. And what does -7 mean? It is actually a loss. So, this -7 tells me that in this combination, that is when I pick R1, the column player picks C4, I will be losing 7. Now, do I need to tell you what happens to column player? You already know that column player will be winning 7. So, this is how these numbers are so much self-explanatory. If I have a 0 over here, what does this 0 mean? That if row player picks R2, if column player picks C3, there is no profit, no loss, no gain, no loss. Nobody wins, nobody loses, because there is a 0. If I put a 10 over here, it means when row player picks R1, R3, strategy R3, and column player picks strategy C4, the row player wins 10 units. For A, it is a +10, and obviously for B, it will be a -10. If we have a -5 over here, it tells when row player picks R3, When column player picks C1, the returns for A are -5. There is a loss of 5. So obviously, when A is losing 5, B will be winning 5. Now see, I am writing everything from perspective of row player. But obviously, it also explains me what is happening to the column player. This is why we say that the game is written from row player's perspective. Perspectives are different. I have won 10 units. My perspective is winning 10 units. I won 10 units. But the other person's perspective will be I lost 10 units. So, whatever numbers are written here, they are from row player's perspective. Obviously, when I win 10, the other will lose 10. I did not tell you each time that I am winning 10, he is losing 10. I will simply say plus 10, plus 17. It obviously means I have won the 17 and he has lost 17. Minus 12. What was the return? Minus 12. It obviously means I have lost 12, B has won 12. So this is why we make use of zero-sum games, that I only talk from perspective of one player and the other player's perspective is obvious. And this is our payoff matrix, and this payoff matrix is written from perspective of row player. Now what are these strategies? These might be a little bit confusing when we are first talking of this. So we'll take an example. We have a row player, we have a column player. Fine. Let's say these are Pepsi and Coke, or maybe a Samsung and iPhone, Apple, Samsung and Apple, anybody. Now, A is exploring strategies that it can implement in the market. A ponders over these strategies: advertising, services, after sale service, and maybe dealer network. As we talked, it is not compulsory, it is not necessary that we call them row player or R, we call them row player or B, we call them column player, it is not necessary. We have Samsung and Apple. Samsung is considering strategies like advertising, aggressive advertising, after sale service and dealer network. At the same time, it is not necessary that Apple will also consider these same strategies. They might be considering different strategies. They might be considering niche marketing. They might be considering buyback guarantee. What will be the buyback guarantee? That when you upgrade to your next Apple phone, we will buy this phone back. So they are considering different marketing strategies. One is niche marketing, second one is buyback, another one could be advertising, another one could be premium pricing. So it is not at all necessary that if row player has R1, R2, R3, R4, column player will have C1, C2, C3, C4. This is the scenario that Samsung is considering three strategies: advertising, after sale service and dealer network. Apple could be considering niche marketing, buyback guarantee, advertising and premium pricing. So advertising both players are considering, but the other strategies are different. Let me take another example to make things clear that how these strategies and everything work, how these play. This is a business example. We'll take a cricket example. As we talked, it is not at all necessary that number of strategies for row player and column player will be equal. We had 4x4 in earlier case, we had 3x4 in this case, we have 3x2 in this case. Let us say this is India. And let us say this is Pakistan. Now, India has won the toss and India is deciding on whom to send to open. They have options of, let's say, Rohit, and then you have Rahane, and then there is Dhawan. We have 3 openers that we can send. Pakistan to bowl the very first over. Now, if it is Indian or Pakistani or subcontinent kind of condition, they might be exploring any bowler. They could even test with some spinner. But if we are playing in England or Australia or South Africa where there are bouncy pitches, probably they might be thinking of some bowlers like, sorry, I do not remember their recent players. Let us say one is Shoaib Akhtar and let other one will be Afridi. Now India wins the toss and decides to bet. So India can send any of these players. Pakistan can send any of these bowlers. Now the catch is, whom do we send first? Does Pakistan decide Shoaib or Afridi will bowl, or does India decide who will be batting first? How do we decide? Now, if these are Indian conditions, subcontinent conditions, maybe Afridi might be given a chance. But if these are bouncy conditions, then definitely Shoaib will be given a chance. These are only speculations. We are not sure what other player will do. These are only speculations. I am trying to read into their mind. That if it is a bouncy track, they might come up with Shoaib. If it is a normal track, even a track which keeps low, a track which is turning, they might come up with Afridi. Second inning, 5th day wicket. Test match, 5th day, 2 sessions, 1 session is gone, 2 sessions are remaining. Probably they might open with Afridi if the ball is if the ball is keeping low, if the ball is turning. They might explore Afridi. So we are not sure who will bowl the first over. So we need to take a call. Whom do we send to bat? Do we send Rohit, Rahane or Dhawan? Who will take strike? We need to decide upon that. How do we decide upon that? I'm not sure. I'll take some chance. Maybe I'll send Rohit in. Now, as soon as I send Rohit in, now Pakistan will decide. Pakistan will decide, should I send Shoaib or should I send Afridi? You are understanding the game, the concept of game. That one player decides some strategy and now the second player will change his strategy, adapt his strategy. Let us say we have some payoffs also. The payoffs are like this: 10 and 6, 3 and -3 and -5 and 8. Can you tell me what is this 10? This 10 tells me if Shoaib is bowling and Rohit is batting, he will hit 10 runs in that over. If Afridi is bowling and Rohit is batting, he will hit 6 runs. If Rahane is batting and Shoaib is bowling, he might be able to get 3 runs. If Afridi is bowling and Rahane is batting, we might get a loss of 3 runs. Dhawan is batting, Shoaib is bowling, -5. Dhawan is batting, Afridi is bowling, +8. Now, if this were the game, how do we play it? You take any chance. You say that I will be sending in Dhawan. If you send Dhawan, if India decides that Dhawan will go out and bat, what are the chances Dhawan will score? Either Dhawan will be scoring -5 or he will be scoring +8. I have taken a call. I have decided that Dhawan will be going out. So Dhawan will either get me -5 runs or he will get me +8 runs. For me, it is decided. I have taken a call. For Pakistan, what will Pakistan decide? This +8 for India means a -8 for Pakistan. -5 for India means a +5 for Pakistan. What will Pakistan do? Pakistan will take Shoaib. Why is Pakistan taking Shoaib? Because Dhawan and Shoaib. I have taken a call of Dhawan. I will get either -5 or it. But Pakistan takes a call of Shoaib. Why do they take a call of Shoaib? Because if Dhawan and Afridi meet, India will be gaining 8 runs, which means Pakistan will be losing 8 runs. But if Dhawan and Shoaib meet, India will be losing 5 runs, which means Pakistan will be winning 5 runs. So what happened? I started with Dhawan. Pakistan now took a call of Shoaib. Fine, no issues. Pakistan has taken a call. Now, as soon as Pakistan decides that Shoaib will be bowling, what are the possible returns? 10, 3 and -5. As soon as Pakistan decides that Shoaib will be bowling, he will either give 10 runs. If Rahane comes, we are not sure, even Pakistan is not sure. So, if Rohit comes, he will score 10 runs, which means Pakistan will be at a loss of 10 runs. If Rahane comes, Pakistan will be at a loss of 3 runs. If Dhawan comes, Pakistan will be at a gain of 5 runs. So, when India decided Dhawan, Pakistan decided Shoaib. Now it is turn for India to decide what is best for India. If India sends Dhawan, it will be a loss of 5. If India sends Rahane, it will be a gain of 3. But if India sends Rohit, it will be a gain of 10. So, whom will India send? India will obviously send Rohit, because he will be making 10 runs. So, you see, I took my first call by sending Dhawan. Pakistan took second call. I took third call to Rohit. And this is how strategies will keep on hopping. Samsung will make some strategy, make a call. Apple will switch. Looking at Apple, Samsung will switch. Looking at Samsung, Apple will switch. So, they keep on changing their strategies. This is what we see in real business, that the strategies keep on changing. Fine. So, this is what we mean by strategies. This is what we mean by possible outcomes, payoffs. These payoffs are written over here. Any payoffs are possible. So, these are the payoffs for Samsung and Apple. If I try to look into these payoffs, if Samsung adapts strategy of advertising and Apple adapts premium pricing, Samsung will be at a loss of 7 rupees, meaning that Apple will be at a gain of 7 rupees. If Samsung adapts after sales service while Apple sticks with premium pricing, in market we are seeing that Apple is going out premium pricing, costly phones, but Samsung has decided to go for after sales service, then Samsung will be at a gain of 8 rupees. Fine, this is how we read into this matrix. Once again, before we wind up, let us take a recap. This is row player, and then we have column player. The game is written according to perspective of row player. This is known as payoff matrix. Payoff matrix, if you remember, we also make use of payoff matrix in decision making. Game theory in a sense is extension of decision making. If you remember decision making, there is one place, there is one step where decision making will be very useful. We'll see when we get there. So, we will be talking of two-person zero-sum games. We'll be having a row player, we'll be having a column player. The game will be written from perspective of row player. These numbers are known as payoff matrix. These are gains for row player and losses for column player. Gain of 8, loss of 8 for column player. Gain of -7, meaning a loss of 7 for row player and a gain for column player. So, this is how we read into game theory and two-person zero-sum games. Next time when we meet, we'll try to solve these questions. We'll try to solve these situations. For now, this was introduction to two-person zero-sum games, game theory, and what are these strategies? What are the rules for these strategies? What are these numbers? Thanks for watching. Bye-bye. Take care.